Good morning, everyone. We'll get started here in a second. So we've got some exciting content for you today, and you'll hear from me first. My name is Mark Docterman. I lead engineering for games and graphics for Android. And today I wanted to give you a quick update on the Vulkan graphics API on Android. As we announced last year, Android is now Vulcan-first. This means that all of our focus and support for graphics is on Vulkan versus older APIs like OpenGL-ES. What does this actually look like in practice for you as a developer and for the OS? It means that over time, Android is supporting a single native GPU API, and all graphic layers, including game engines, graphic APIs, other graphic APIs, and the system UI, will sit on top of Vulkan in this dramatic layer cake. In 2025, we passed an important milestone for Android. More than 50% of new games launched in the last 6 months on Unity are now using Vulkan. This has been a long time coming. Furthermore, nearly 100% of all devices running Android 14 or higher now provide Vulkan 1.1 functionality or higher. This makes Vulkan availability a thing of the past on newer devices. Recent games that have shipped on Vulkan include Game of Thrones, King's Road, Deep Rock Galactic, and Dredge. If your game or game engine is targeting Vulkan, you'll be glad to know that we're constantly raising the requirements for Android. In Android 17, interesting new extensions like multi-draw indirect are now required on new devices, which gives you more possibilities for scaled rendering. If you want to get an idea about the ubiquity of Vulkan features and extensions on Android, reference the latest Android Vulkan profile 2025. This is something we do on an annual basis, and it gives you an indication of the coverage for more than 80% of active devices. You can use this as a reference if you're considering a particular extension or feature. How well covered is it in the entire Android ecosystem? Here's what I want you to take away from this update. Going forward, all new Android phones and other popular Android form factors will no longer require a native GLES driver. We recommend all games to use Vulkan, but for existing older games and games that cannot switch to a Vulkan backend, we're providing Angle as a solution. Angle is our OpenGL emulation layer that runs on top of Vulkan. Soon, game developers like yourselves will have two choices. Use Vulkan as the graphics backend on new devices, or opt your game into using Angle for GLES emulation. We find that the performance and the cost of using Angle is rather nominal, in some cases better, in some cases slightly worse, but it gets us all onto the same Vulkan layer. To prepare for this transition, we recommend you start testing with Vulkan and Angle today, depending on your situation. To test your game on Vulkan, it is likely that your game engine already supports a Vulkan backend. Choose this backend for recent devices. To test your GLES game with Angle, refer to the article and the link posted there on our developer site, and let us know if you run into any issues. Thank you for your support, and I'll now pass things over to Stephen, who will tell us more about 16K pages.
Thank you, Mark. Hey, everyone. My name's Stephen Moreland. I'm a software engineer on the Android systems team, and for the past 10 years, I've worked on how Android interfaces with its hardware. Today, I'm going to be talking about some of the changes that we're making with how we interface with memory in Android. That is, I'm going to be talking about 16 KB pages. Now, I hope you've heard of this. But if you haven't, please pay attention, because this is something that we're requiring all apps to do. So before I get into the technicals of what this is, or what we're doing and why, and so on, I'm going to talk about why we're doing this. So what does 16 KB pages get us? This is a change that we're able to make on certain hardware, which allows us to get next year CPU performance 1 year later. So it's an overall setting that we need to apply from the lowest layers of Android all the way to the application layer, which gives us much faster performance much earlier, and I'm really excited about that for the performance that it will give us for our games. So what exactly is 16 KB pages? Well, it says it right here. Page size is a granularity that the hardware and the OS deals with memory. But what does that really mean? So when your application requests a page on an Android device today, it goes to the kernel, and the kernel goes to MMU, and it sets up 4 kilobytes at a time. And so you ask for memory, and it sets up 4 KB, and you ask for memory, and it sets up 4 KB. With 16 KB pages enabled hardware, we're able to request 4 times as much memory, 16 kilobytes at a time, which reduces a lot of the overhead in the memory subsystems of Android and gives us a smoother, better performance overall for the entire OS and all applications on it. So one thing to note here, 16 KB pages is only for ARM64 hardware, which is really common on Android. And Java code will just work out of the box on 16 KB pages, but native code needs to be 16 KB aligned. And this is a compiler option in most cases. And additionally, there are sometimes some runtime behavior things. So if you're doing low-level programming, maybe in a game engine, and you're using mmap, addresses there also need to be aligned, but this is much simpler than, say, the 32 to 64-bit migration. And one other difference, finally, is that game binaries are universal. So what does that mean? If you have a 4 KB binary, 4 KB aligned game, this will work on 4 KB devices, but it may crash on a 16 KB device. Once you align your game to 16 KB pages, that's going to work on a 16 KB device and a 4 KB device with the same binary. So we're not adding any logistical overhead at all for this. Okay, so I just talked about the technical overview. Now I'm going to talk about where we're at in this migration and what we've done in the OS to enable 16 KB pages. So the big thing is, in Android 15 Plus on select devices, such as the Pixel 8 and the Pixel 9, there's a developer option. This is optional for OEMs and SoCs to implement. And if you go into your developer option, you can boot the device in 16 KB pages here. And one thing to note is that today, this does require you to wipe the device. So it has to be a development device. However, if that doesn't work for you, we have plenty of other options with Android emulators and virtual devices where you can try out 16 KB pages elsewhere. Additionally, you can expect launches in the near future with 16 KB pages, especially on high memory devices where we have more memory that we need to optimize to be able to use faster. And then as of last November, all games are required to be 16 KB aligned. So there are a few waivers and exceptions for that now, but this is something that we're pushing for the whole ecosystem to adopt. Okay, so let me dig into a few details with the performance that we're seeing. I talked about how the memory subsystem is able to run 4 times faster, but what does that mean in practice? So we ran a few industry standard benchmarks. PCMark, you can see we got about 8.7% faster. Geekbench, we got 2.5% faster with some sections, specifically those that are bottlenecked on memory, getting 7 to 9% faster. Also, transactions, the Android system, large ones, are about 20% faster or more. And also, one thing to note is that this comes with a memory increase of about 3 to 5% overall on the system. And this is largely offset with more efficient reclaim. What that means is that when we're running low on memory, we can more efficiently go and put things to cache, put things to the disk, close things down, and get pages back to make them available. And in practice, we see that that the number of background application kills or visible application kills actually improves with 16 KB pages. However, in some cases, for instance, if your application is allocating or memory mapping 4 kilobytes at a time, there may be some wasted memory on 16 KB pages, so you may want to investigate that. Finally, we ran a set of tests on 7 representative games that we feel is representative of performance on Android today. And what we saw is that at peak times, we got an increase of 2 frames per second, up to 2 frames per second as we're hitting that frame cap. And for the first 5 minutes of play, an additional 3 frames per second of savings without any other optimizations, purely from reducing some of these memory bottlenecks. Finally, we saw up to 7.4% power reduction, meaning that people can play your games for longer. All right, so I've talked a little bit about what 16 KB is and why we're doing it, but here's what you actually need to know in order to make sure that your game's compatible. So all the information in the slide deck and even more is at this link here, developer.android.com/16kb pages. And what you should know is that most tools today work with 16 KB pages out of the box, and they have for a while. So if you're using NDK 28+ or Gradle 8.5.1+, it's gonna build with 16 KB support right out of the box. Additionally, most major SDKs support this today. So I called out a few here: Unreal 5.6.1+, Unity 2021, 2022, and Unity 6. And newer versions all support 16KB right out of the box. But the real takeaway is that if you want to make sure your device works, if you want to make sure your game works on 16 KB pages, the only way to know is to test it. So we ask that you please test your game on a 16 KB device or emulator to make sure it works. And after that, you can enjoy increased performance on 16 KB. All right, thank you, everyone. I'd like to invite my colleague Val up to talk.
All right, hello, I'm Val O'Donnell. I'm a developer relations engineer at Google Play. And today I want to talk about premium games on Google Play. So the first question is, why port to Play? Well, we have a very active gaming community. There's a lot of Android users, a lot of them are gamers. And more than that, we've got big device reach. So in addition to mobile, we support PCs, Chromebooks, foldables, XR, and tablet. And this is all wrapped up in our ecosystem supported by a buy once, play anywhere model. And this means that players can play across devices seamlessly. So I want to talk a little bit more about the buy once, play anywhere idea. So it's a cross-platform ownership model. And that means we've got common billing across different devices. We've got a unified library and progress syncing between devices. So there are two parts to this. And the first thing is the Play Game Services, or PGS. And this is a portable player ID, enhancing mobile games. So it gives you access to achievements, seamless restore, and this means that players don't need to manually sign in. They don't have to create a link with another ID system, and their progress syncs seamlessly across devices, hence seamless restore. With the same PGS, you also get leaderboards and cloud save. So cloud save brings me to the second part of Buy Once, Play Anywhere, which is our saved games API. So this is a part of PGS, and it's a cloud storage solution that lets your players save progress on Google servers. And it's really simple because you don't need your own server, you don't need to deal with cloud save, and we actually have an out-of-the-box UI that can handle save slots, cover images, and descriptions. Additionally, the data saves on the player's Google Drive, and also, if they're offline, they can save locally and sync again later. So this is a robust system with a very simple setup, and it adds a lot of value. And on that note, I want to talk just a very high-level overview of what that setup entails. So if you want more documentation, please scan the QR code or check out the link below. But essentially, first you're going to go to the Play console and enable Play Game support. And then in your code, you're going to obtain the snapshot client object and call the getSnapshotContent method, pass in the activity. And for displaying, again, there's that out-of-the-box UI that I mentioned. And I also want to say that you can integrate the Snapshot API any place you want your players to be able to interact with save games and restore their progress. Finally, for writing and loading games, that's an asynchronous call to Snapshot's client open. So again, check out our documentation, but it's a pretty straightforward process from start to finish. Okay, so now that you want to port to Play, I want to talk a bit about what we're going to do to support you when you're here. So one of the things we have is free trials for games. This does just what it says on the box. It's going to lower the barrier for getting players to try out your game, right? It's going to showcase the quality, players can get involved, love the game, and it's also going to communicate really clearly that this is a paid game, and that can avoid frustrated players. Maybe they didn't understand it was a trial, so it's really important to communicate that very clearly. It's also really simple because only one listing is needed for both the trial and the full game. And finally, players can continue their progress after purchasing, so it's a really good experience for them. Okay, so that's free trials. We've also got Play Pass. That's a subscription of curated games. So again, another way to lower the barrier to get more people playing your game. It makes it really easy for new players to find and try out your game, and it gets your title featured in our dedicated section of the Play Store for increased visibility. And finally, it's also simple to implement because the Google Play Billing API supports both standard and subscription models. So we also support wish listing. And of course, if the game isn't ready or the player's not ready, no game gets forgotten, right? They can wish list pre or post-launch, and they'll get a reminder when your game launches. Wish lists sync across devices. Again, this buy once, play anywhere model. And wish listing also supports improved recommendations and promotions, which helps us get your game in front of future players and make sure players are playing games that they're excited to play. And finally, I want to talk about discount support. So this is, driving player engagement with discounts and rewards. And we visualize discounts with strike-through pricing for clarity. We also do feature discounted games in high-traffic areas like the Offers tab and the U tab. And Play Points can create targeted loyalty programs to reward your players. Okay, so now I've gone over why you want to come to Play, how we're going to support paid games, and now I just want to end with some very quick porting tips. So some really fast wins, of course, optimizing settings for Android. Pay particular attention to texture settings. You want to be using ASTC, Android texture compression. You also want to think about simplifying lights, cameras, shaders. Can you swap out floats for ins, for example? Even these small gains can be a great place to get started. And then also make sure that your dependencies are supported on Android. And this is pretty important for the scoping phase to get a sense of the work that's going to be required. And finally, use available tools. So for those of you building with Unity or Unreal, we've got PGS for both engines. We've got PGS for Unity or PGS for C and C++, as well as our ADPF plugin. So overall, I hope you can see the value in Play, how much we're doing to support premium games, and what a good experience it is for players. But you don't have to take my word for it. I want you to please welcome Emil Kerr to talk about porting Deep Rock Galactic Survivor.
Good morning, everyone. My name is Emil. I'm the head of product at Fun Day Games. We're a game studio located in sunny Aarhus, Denmark. Well, okay, right now it's snowing, so the weather here is much nicer. But at Fun Day, we built games for 14 years, and we're proud to develop games with both our own original IPs, but also partner IPs. I'm here today to talk to you about one of our most successful partner IPs to date, Deep Rock Galactic Survivor. And I'm going to talk about how we adapted it from a PC-first title to a title that can be played anywhere. If you like stats, get your cameras out, take a picture. I'll be brief. So what started out as a simple prototype, you can see it on the GIF there, hit Steam Early Access in February 2024, and it completely blew up. By the time we launched into 1.0 and our mobile port in Q4 2025, we've crossed over 3 million units sold across all platforms. Mobile metrics, I think, speak for themselves. It's at price parity with our PC version, and we're seeing double-digit conversion rates and players spending hours daily in the Mines of Hoxie's. We're extremely proud of this, and we think it's great. But how did we get there? I'll get to that. But basically, we see Deep Rock Galactic Survivor as a great game that travels well across a lot of different surfaces. So no matter if your preferred platform is Xbox, Steam Deck, your gaming rig at home, or your phone, we want to make sure that it's easy to pick it up and bring it with you everywhere. So to set the stage, here's a brief timeline of how we got to where we're at today. We started the porting in March 2025. That's when we sort of got very serious about the talks about this. This happened while we were still very actively developing the game, so it launched in early access in 2024, like I said. So at this point, we were still very actively developing the game. In September 17th, we released 1.0 on Steam, Xbox, and PC, and then 6 days later, we announced mobile, ran a pre-registration campaign, and then finally on November 12th, we released the game on Google Play ecosystem with phones, tablets, and Play games for PC. But porting a live game requires a strong and established process. So when we started developing on porting the game to mobile, our core development team back home were still very locked in to their own set of goals. They were working in their own Git developed brains, and they were completely focused on the 1.0 deadline at hand. That's adding new biomes, expanding the PC game scope, listening to feedback from players in early access, like all of the complicated things that go into operating a game and improving it with the players in the community. So, that's happening, and that's busy and hard enough. Now, to handle the mobile port in parallel, what we did was we spun up a separate mobile develop branch on Git, and this was where our mobile team could focus their efforts. Funday steered priorities and informed the teams on changes, and we could monitor and would let sort of the mobile team know what was happening. We worked closely together with Pictiv in Sweden and Unity Technologies in order to make this happen. So Pictiv handled UI and general optimizations, while Unity did targeted deep dives and very sort of deep technical improvements. So the finer details of how we structured this is a talk in and of itself, and I only have 20 minutes. So I'm not gonna bore you with like all the details, but if there's one takeaway I want you to take away from this, and the way that if you're thinking of doing this yourselves, I would recommend you do daily stand-ups. Don't treat your subcontractors, the teams that you work with, as separate entities and let them off on their own. Sit with them, work together, inform them of what's happening on the main line of your game so they can deliver a better experience. Take ownership of the sort of product decisions that you need to make, because that's the way that you can really ensure that you deliver a very high-performing game. All right, so we have a process in place, so now we need to find some sort of a goal, that shared goal that I was talking about before. So for this, we laid out 3 core goals for the port. First, we needed to adapt it to mobile. So we treated phones as a premium platform where we wanted to make sure that the game felt perfectly natural to play, no matter if you held your phone in portrait or landscape. Right from the start, we were very convinced that survival would be a good fit, but we didn't just want to take the PC version and just, slap it on a phone and call it a day. We knew that we wanted to make deep improvements to the game in order to make it really fit like it belonged on phones. Second, high performance. We wanted to reach a massive mobile audience, and that also meant that we needed to make sure that it ran well on, internally we call it toasters, like everything from like the high-end Pixel 10 Pro Fold kind of devices, but also the older legacy devices as well. So we wanted as wide a support as possible. So in order to do this, we knew that significant optimization was needed to make that work. Finally, we also needed to make sure that it fit the new home. The new platform would be Google Play and the ecosystem. And that also meant fully embracing all the development tools and sort of opportunities afforded to us by being on Play. So for us, a successful port, like I said, isn't just about pushing a PC game onto a smaller screen. It's about making sure that the game respects the platform and it feels like it belongs on the platform where it lives. So respect the form factor, demand high performance of the game that you make and leverage the native tools available to you. So let's get into some details. The first big task we did was we wanted to adapt the game from running on landscape and adjust some UI and work out how to deal with things like virtual joysticks, camera positioning, balancing, stuff like that. So we got things up and running fairly quickly. We got it both in Figma, but also on device. And we're very happy to sort of see it play well in the core game. But one thing is seeing those first few screens work well on device is something completely else to deal with the mountain of meta screens that you've built into your game. Deep Rock Galactic Survivor is a very information-dense game, and there's things that we had to chug out that didn't make sense on mobile, like key rebindings and specific settings, while there were also other elements that we needed to add to adapt it to the platform. So things like try before you buy, a shop, in-app purchases, and a way to sort of sell DLC in the game was something that we needed to add in. There were also screens that needed significant modification to work on mobile. So something that can easily fit on a large screen or on your console at home. We needed to turn some UI elements into tabs or carousel interfaces to make it work on touch. Also make sure that it worked both in tablet, foldable, and 9.16 and 16.9. So the decision to support both landscape and portrait meant that we had to deal with all the UI at least twice, sometimes more than twice, right, to make sure that it really fit. So if you're thinking of porting a PC game, don't underestimate this part of it. Be very good friends with your UI artists. Bring them treats. They'll have some long work, like long nights ahead of them. But you can plan this in from the start, and you should. Right, performance. One of the big undertakings in this port was a full replacement of the pathfinding system in the game. This was developed over several months by Unity Technologies, one of their engineers called Ronan. He worked on this tirelessly, and he really delivered great work, the entire team did. The move to flow field pathfinding instead of the Unity sort of native nav mesh system meant that we could lower the cost of navigation in-game. It is a crucial lift for those moments where the players need to navigate the complex mazes and all the glyphids need to swarm you, not just like 10 or 50, but hundreds of enemy entities that are sort of following the player around. So the move to flow field navigation meant that we could cut navigation costs by 60% on peak frames. Massive improvement. But when you swap something out as fundamental as the navigation system, you get to have a lot of fun issues. So here you see footage from an early build. I don't know, like, how many have played Deep Rock Galactic Survivor? A few, okay. If you don't know, the enemies are not supposed to do that, like bounce around and fly. Like it's bad design, it's not easy to, survive, which is the whole goal of the game. So this wasn't great, and this is what you get when you swap out a fundamental system to a game that's so dependent on navigation and enemy behavior live on a game. So not only do we have a game that was live on early access and a ton of, like, millions of users who were accustomed to how navigation should feel, we now needed to make sure that we could match that expectation in the new sort of pathfinding system. So what this meant was that we're basically doing the Indiana Jones idle swap on a game with millions of active players where they really know how it's supposed to feel. I'll get back to like how we made sure that we nailed that perfectly, but basically if you're going to do a complete system swap, think if you really need to, we had to. Also make sure you have enough time to review, balance, and iterate on it. Work with your designers, make sure that they take the time out of their busy day and schedule to prep for that 1.0 launch to sit and actually make sure that this feels great too. So for our PC launch, tech art and design really liked Unity's VFX graph. Visually, it allows us to make things that look really amazing. But we also knew that it was an experimental package. It was marked experimental for mobile. So we sort of were aware that this could be a risk going into porting. The result is that when players triggered specific particle systems that used VFX graph, this would happen. So massive stuttering and ultimately crashes on devices across some sort of affected Vulkan devices. So, advice one here is if a package is labeled experimental, believe it and think hard about if it makes sense. For us, it made sense to stick with VFX graph. It allows us to make really nice things. So what we did was we had to triage. So for us, gameplay comes first, of course. So an enemy attack telegraph or particle system that sort of tells the user like there's something bad coming in your direction, now you need to dodge. That's way more important than like a smoke particle system. So for a short-term solution, we monitored Crashlytics and used Firebase remote config to force problematic devices onto OpenDL. This stopped the crashes, basically stopped the bleeding, right? And we didn't punish users who had fully compatible Vulkan devices. The long-term cure here, of course, is to port all the critical systems to Shuriken and have multiple particle systems in the game at the same time. Huge shout out to tech artists in the room. If you're here, I see you do amazing work. And for situations like this, I recommend you to ally yourself with tech artists because you'll need their help to port all of the particle systems. For us to be able to do this, we work closely both with our own internal tech artists that were able to come in and save the day, as well as tech artists from Unity. So we managed to clutch it at the end. Now, platform achievements. I don't know if you know, but on Steam and on the other platforms, we have 300 achievements. We didn't want to settle for anything less than 300 achievements when we moved to mobile as well. So to achieve this, we actually worked very closely with the Google Play team and then the Google Play engineering team to achieve and expand the limits on achievements. So today, the limit is 500 achievements on Google Play, which is very exciting. So we've helped raise the roof for everyone. So don't hold back on achievements. But speaking of achievements, what should you be aware of when you come from PC? Well, we were the first game to get over 300 achievements. We're very happy about that. So a few tips on that. Like, first, achievements are cool. Players really like it and they respond well to it. It drives engagement and just like they keep playing. And for a certain cohort of players, it's a reason to keep coming back, competing with their friends and just really, be better than everyone else. But if you're doing something like this, the Play Games Services publishing API is your best friend, especially if you have 19 different languages like we do, like localized for localization. So a word of warning, if you're coming from other platforms and bringing your PC game to play, be aware that there's tighter restrictions on text limits So there's a ceiling on how long the title of your achievement text can be, and also there's a ceiling on how long the description can be. So plan your achievement text with mobile in mind from the start. Don't wait until you're out and then you have to retool it. Trust me, I know. I spent a lot of time like trying to slim down the text and make sure that it won't fit. Make sure that it fits mobile from day one, especially for localizations and especially for localizations, since some languages just are very wordy. Shout out to all the Germans in the house. You should never underestimate the length of German words. All right, we're almost at the end here. There's just one final point I want to make, and it's about playtesting. So during the development of Deep Rock Galactic Survivor, we leveraged testing a lot. That's also true for the PC version. We had testers for this on-site in our offices in Aarhus, as well as distributed wide-scale tests across several weekends where we recruited over 600 Discord players from our community. So yeah, in-office focus group testing during early development when things weren't announced and we were still sort of working on it, and we tested both on fans of Deep Rock Galactic Survivor and also people who had no idea what the game was, because we wanted to make sure that we could appeal to both. Like I said, we had some of the more hardcore fans, the people who really knew how the movement system was supposed to work. So once we've done our first internal passes, we could send it out to the Discord testers that we had, and they would come back within hours with a bunch of feedback on like what we needed to adjust to really make it work better. So some of the takeaways from testing were very obvious, like adjusting fonts, but others were more subtle. So QA, right, they'll verify that your landscape mode technically works. You can go into settings and you can change your game from portrait to landscape. What they won't tell you is that users don't find that easy to navigate, or like don't immediately understand that they'll be able to change from portrait to landscape. So our community told us that they didn't even realize that they could turn their phones around was an option. So that feedback made us add callouts to our loading pages and splash screens. So this is the kind of stuff that QA won't catch, but your fans will catch immediately. So definitely sort of remember to use your fans. Remember to test more than just the game as well. Like when you're in pre-registration phase, you can also test the packaging of your game, your app icon, the store description, and the screenshots and the videos that go along with your store listing. This is an immensely powerful tool, and it's something that really makes it possible for you to optimize your store page before you launch. I highly recommend you do it, because like with the kind of exposure that you can get on a platform like Google Play, the difference between 5 and 10% is massive once you start to look at the numbers of installs that come in. So before I leave you with a short video, I want to sort of go through the good and the bad parts of this project. So let's start with the bad dwarf stuff, right? So VFX graph, we didn't plan for this. This sort of just suddenly was a problem that we had to deal with. So I recommend that you build a test scene early and test on lots of devices. If not, your tech artists will get hit with massive unplanned porting tasks, and you'll have to buy them candy to convince them to help you. Another thing is, for us, we decided to go with this like try before you buy. So it's basically a free demo that you can download, and then we limit you to one biome, a selection of specific dwarves, and then you can play that for as long as you want. But that also meant that we had to build in an in-app store, a way to run sales, a way to run and sell DLC. So that takes integration time. So make sure that you plan that in from the start and have time to do several iterations, because this is where the conversions for your game is going to come from. You could also consider using the new trial system that Val was talking about from Google Play. I think that's an extremely valuable tool as well that would massively lower the cost of doing something like this. All right, so moving on to the good stuff. Working as a single team with the developers that you do the porting with is extremely important. It makes it possible to make something that feels like it's the same game everywhere, which was one of the key goals for us. And treating our partners at Pictive, Unity, and Google as one unified team with shared goals meant that we always knew what was happening, so did our partners, and no one was left in the dark. Another thing is leveraging your community. So our in-house community caught bugs that QA missed, and we actually tracked mock review over time. So we asked them, like, if this was on the Play Store, how would you rate it 1 to 5? And that was with that, we were able to sort of evaluate and gauge launch readiness as we were getting closer and closer to the release. Finally, working closely together with the Google Play team involved. Huge shout out to our friends here on stage today. With me today, they helped us squeeze every drop out of performance out of this. Was invaluable. They provided great guidance and really made sure that we could make the most of the move to smaller screens. So porting a PC hit to mobile isn't about shrinking your assets and just pushing it live. It's about expanding your team and the other scope to make sure that you can do it right. So rely on your partners, test your game early, and trust your community. This concludes my part of the presentation. So thank you for your time. Feel free to find me after the talk if you have questions about Deep Rock Galactic Survivor, and any questions you might have about how to port your game from PC to mobile. I'll leave you with this fantastic launch trailer that the Google Play team made for our launch, Rockin' Stone. Oh no, wait, how do I start it? There we go.
With Google Play Games, you can play unlocked. Unlock a free biome, free class, and free mission across mobile and PC, so you can get straight to the swarm. Go play Deep Rock Galactic Survivor on mobile and PC with Google Play Games. Download now.
That's it. Thank you for listening. I'm going to give it up to Simon.
Hello, everybody. So I'm Simon Cook. I'm a developer relations engineer in Android Games DevRel at Google. I'm also part of the leadership team for our graphics profiling tools. Before this, I was in the Xbox Advanced Technology group for a decade, and I worked at Midway Games and a few other places around the industry. So part of this session is all about the direction we're going in with our profiling tools for Android, especially regarding games and graphics profiling. But first, let's do a quick recap. So back in 2017, Google released Perfetto. You can think of Perfetto as kind of a front end over a whole bunch of different profiling and trace systems in Linux and Android. It also provides a low overhead mechanism for capturing event traces, as well as data from other data providers. And it even has its own web app UI for analysis. Now, at first, it didn't support GPU counters, but later versions added support for that, and you can see that in there today. Roll forwards to 2020, and we reached the release of the Android GPU inspector in beta, although I suspect that in 2020 you might have had a few other things on your mind. So you'll be forgiven if that managed to slip underneath the radar. AGI supported system profiling, that is, like Perfetto, it did wall clock time analysis of system event traces. It also supported frame profiling through API call capture for Vulkan. And as part of the rollout of Android 11, it supported GPU counters on specific devices. Now, your GPU vendor, of course, as everybody knows, already has their own selection of outstanding tools that unlock deeper understanding of their specific hardware. So, for example, we have ARM with the Streamline Performance Analyzer. Imagination Technologies has their awesome PVR Tune tool. Qualcomm has the Snapdragon Profiler. And Samsung just announced this week that for devices with an Xclipse GPU, they are releasing SOCTOA, and it's available in open beta. So I encourage you to go check that out. Now, why do we need a new graphics profiler if there's all of these other tools? Well, we've heard a lot of feedback from frustrated game devs that our basic graphics profiling story in Android is kind of incomplete, or that it's hard to find the tools that you need to succeed. And many of you want a single tool that will allow you to analyze your game and figure out how to improve its performance on all of your devices, not just one. So we'd like to try to fix this and make it better for the entire Android ecosystem. Now, I just mentioned that everybody's got OEM and IHV tools already. Well, we're not trying to eliminate those. We'd like to become the first tool that you reach for in your toolbox, but not necessarily the last. There's a continued need for a first line of defense tool, a tool that you would use to start your performance analysis, and one that works across all devices. So this is why we're looking to take the work that we did in the Android GPU inspector to the next level. We're not replacing the IHV tools. We can't. They support other platforms as well. We're working with OEMs and IHVs on this profiling effort. We've been having conversations with them now for about a year, and they're excited to come along on this adventure with us. And we're improving and updating Android conformance tests to ensure that future Android devices will support the profiler. So you can think of our new Android GPU profiler, which will be shipping in open beta later this year, as Android GPU Inspector, the next generation. So we're collaborating with Samsung, and we have been for a couple of years now, to produce an open source hardware agnostic profiler that works for all Android devices using Vulkan. And it's built on top of Perfetto for system tracing and on top of LunaG's graphics reconstruct API to perform graphics capture and replay. You might be wondering, what does all Android devices with an asterisk mean? Well, Android 12 and later devices, plus a handful of Android 11 devices, support GPU counters for profiling. GPU counter support is now an Android requirement, it has been since then, and that enables frame capture and replay via graphics reconstruct, because that allows us to get measurements of the GPU performance back out of the system. Future Android devices will have better GPU profiling capabilities standardized across OEMs. Now, if you go back before Android 11, you're going to be dealing with just system trace level performance information. So you won't get as much information out of that. But if you go to the OEM tools, you'll be able to use them. Now, who's this for? Well, at first, we're going to target the experts. And the reason for that is if we create a tool that's great for experts, then when we add ways to simplify it for new engineers who aren't as experienced with performance analysis, we'll be able to make it easier for them, but still make sure that the tool does everything that everybody else needs. It's going to be targeting performance-minded graphics and rendering engineers who are using Vulkan to make games and other graphically intensive experiences at first. It's built for game and game engine developers. And we have a lot of people in our early access program right now who are starting to kick the tires on this from across the games industry. And we're also targeting GPU developers, GPU driver authors, OEMs, and graphics library authors and system engineers. Because if the people building your OS are using our tools to optimize their work, then you can guarantee it's going to be pretty good. So what can it do today? Well, you might recognize this if you've ever used AGI as a very similar looking capture interface. It's a visualization tool right now for analyzing performance traces. It auto-injects Vulkan layers to augment the trace with additional information such as Vulkan call timings, debug info, and adding screenshots, which is a new feature where as you take a system trace, we're going to periodically take a screenshot so that you can see as you navigate through roughly what's happening on the device. It's also going to analyze workloads system-wide, so you can see everything that's happening on the device, not just inside your game. It shows GPU counters for GPU activity on a timeline-like trace, and it shows frame timing and presentation information from Surface Flinger. And it looks a bit like this. Now, I don't have time to give you a demo in this session because, as you can tell, it's pretty packed to the gills, but I'm going to show you some screenshots. So here's an example of a frame from the order-independent rendering sample from the Vulkan samples. This is showing GPU activity pinned to the top, frame boundaries based on acquire and present. And this one is a side-by-side trace. You can open the same trace more than once and do comparative analysis. This is a feature we're hoping to improve and add more functionality to over time for both comparing within a trace and for longitudinal testing. When you're doing performance regression testing, you want to A/B test two different builds. And then this is an example of the screenshot feature. You can see underneath the frame timeline there, you can hover over one of the screenshots and see where you are in the game. This is really handy for navigating through a longer trace. So, in terms of features, the system profiler is coming online first. This is best for system-wide timing analysis, finding slow frames, and seeing if you're CPU or GPU bound. It will allow you to analyze perf, thread, CPU perf, and the effects of scheduling, and use GPU counters to understand power-hungry scenes and bottlenecks in your game. The frame profiler is going to be coming online later. We are actively working on the frame profiler. It will allow you to capture Vulkan graphics calls and graphics resources for later playback and measurement, allow you to do in-depth analysis of captured graphics calls, replace traces on device for reliable subframe performance measurements, for example, render pass timings, and it will give you frame timing for all major IHVs. What's going to come later is newer technologies. So we're going to start out by focusing on more traditional rendering techniques, fixed function pipelines, things like that. Later, we'll be focusing on analyzing GPU-driven rendering, compute shader analysis, and ray tracing analysis, but that's not going to light up probably this year. The first phase of Frame Profiler will focus on performance analysis capabilities. Graphics debugging will come later. Debugging is an important scenario for us, but you have other great tools that are available to you right now, such as RenderDoc, that you can use. So we're going to deprioritize that a little bit because we can get to that later. And if you're wondering how this will ship, it will ship as a standalone profiling tool. One of the most common pieces of feedback we get around our tools, especially profilers, is that you need it to run as a standalone thing that you can install with pretty low overhead on an artist's desktop machine or a QA engineer's desktop machine so that you can try it out and not have to install all of Android Studio on their desktop. It will also ship integrated into Android Studio, so available where all of the other Android Studio profiling tools are today. And finally, it's going to ship as open source available on GitHub. So we will happily accept pull requests. And if you feel that there's functionality that you need that isn't coming online fast enough, it will give you an escape hatch that will allow you to integrate your own functionality when you need it. Now, in terms of timeline, the system profiler is in early access right now. Unfortunately, there's only a few of us, so we can't invite everybody to join the early access program at this point. But I encourage you to sign up for it on the QR code that will show up in a second. Around the middle of this year, we're planning on releasing the system profiler in open beta, and I would definitely encourage you to sign up for that. Near the end of this year, the Frame Profiler Early Access program starts, and in the future, we are all ears. We need your feedback on the tools that you need to make better, more performant games, and we would love to get that from you. So, how do you get it? Well, we're opening up the profiler to early access, open beta, and you can sign up with this form here on the QR code and decide if you want to be part of the early access program, the open beta program, or be notified at launch when we finally release it. If you don't get into the early access program, you'll be automatically added to the open beta when it starts up. Anyway, with that, thank you very much, and I think we might have some time for a few questions. Awesome, thank you.
I can just project, or, oh, this works. I had a question about the stand-ups. I feel like when I have daily stand-ups, I can't find things to talk about. So I'm wondering, how do you get the most value out of the stand-ups that you do?
For me?
Yes.
Good question. So the question is, like, how to get most value out of the stand-ups with the studio? I think it depends on the team and the producer, right? So for the external companies that we work with, it was both Unity and Pictive and then ourselves. So it depended on, like, some days it would just be a very rapid round of stand-ups where it's like, yep, we're still working on the same thing that we talked about yesterday. Cool, by. And then there's other days where it's more complicated, where I have to go and tell them, we're adding a gear system. And then they look at me like wide-eyed, and I have to tell them why it's important and talk about, okay, well, how do we then ingest this into the pipeline, and who needs to be involved? So usually, whoever has strong opinions about something, they'll let me know, and anyone else who just really wants to get back to do model decimation or optimizing assets, we'll let them go their own way so we can have a deeper discussion on it. But really encourage you to I think the key here is to be transparent and open with the communication. I'd rather overshare, and then if people feel like they don't need the information, that they have enough on their plates, they get to go. But if they want to know where we're at and what we're working on, that information is always available to them. They shouldn't ask. It should just be a very open book. Yeah. Does that work? Okay.
One quick anecdote I just wanted to share on that subject. So I used to be the client lead at Niantic, and when we were building Ingress, we were a small company, small startup within Google, and I'm talking engineering, product management, biz dev, support. The entire team was roughly 35 people. We would do a stand-up every day across the entire company, and we were able to do a 35-person stand-up in less than 15 minutes. It's all about building trust with your team and asking them to show up and be present and be able to give a very succinct way of communicating and respecting each other. Most stand-ups fail because fundamentally people feel like they're dragged into it and they haven't really prepared. If you can build a culture of trust and preparation and respecting each other's times, you can make stand-ups work. But it's tough. It definitely takes work.
Thank you for the presentation. So my question is for your GPU profiler. So you said you built it with the GFX reconstruct for the capture and replay. So I want to hear your idea. Why don't you use Randog for that part?
That's actually a really good question. I think the big reason why we don't use RenderDoc as the heart of the profiler is that we're deliberately targeting graphics reconstruct, because that seems to be the direction that the Kronos Foundation and Vulkan are going in for doing this kind of graphics capture work. And that's probably going to be the most actively maintained mechanism for recording this going forwards. So yeah, I think RenderDoc probably is at the wrong part in the stack to build it into the profiler.
Okay.
It definitely provides us the most coverage for the type of captures we need to do. So we're using the best tool that's available, and it's something we're actively improving. It's capturing Vulkan and successfully recreating it each time, especially with its evolution of user-controlled memory and other things, makes it really difficult to capture and replay successfully. So it's the best solution for Android.
Thank you.
Hi there. My question's for Emil. I'm really curious about the decision to support the game on both portrait and landscape mode. And I was wondering if player numbers on each was something you tracked with analytics, and if so, how they compared to one another.
Yeah, so great question. I think the reason for it is because we felt it was more natural to play. So that was sort of to the point of fitting the platform. We did an early test in November, December, just to sort of see how it played in both portrait and landscape. We knew it would play great in landscape, right? But it's a very thumbable game, so I don't think all games are suited to be played with, one hand in a very sort of relaxed manner, like portrait. But for us, it just made a lot of sense. Let me think. The technical challenges with it, we went in it with open eyes because as a studio, we've also done mobile before, so we knew what it would take to also get it through to the finish line. But it's worth it. And then the other question was around, what was it, player numbers?
And yeah, it was just about whether you were tracking
percentage of
players on each.
The default mode is it starts in portrait. So the vast majority of players are playing in portrait. I don't have exact numbers, but off the top of my head, it was 70% are playing in portrait and then 30% in landscape. That being said, if you're really hardcore into it and you come from PC, offering landscape just makes a ton of sense, especially if then you have a backbone or a game controller we don't have metrics and sort of the overlap there, but I would assume that the majority of people who play with the game controller would like to play it in landscape.
Fab, thank you.
Yeah.
Right. Question for Simon. You mentioned that AGI is going forward, like a lot of plans for Vulkan and all that. And I wanted to know, I know that Vulkan is the standard and it's pushing that way, but I wanted to know if there is any plans going forward from now to deal with GLAS and similar APIs or similar versions of different versions of GLES.
So with there's no explicit plan to support GLES as a top level way of exposing render calls, but we do plumb through a lot of information from the GLES calls for Angle. So you can actually run your game on Angle, profile it using the profiler, and see the calls as they come through. It's we're targeting Vulkan first because that's the direction that most of Android seems to be going in. But we will, we're obviously looking at whether or not we should provide support for doing OpenGL analysis as well. If you find that the way of doing it through using Angle doesn't really meet your needs, let us know, and we'll definitely add that to our discussions internally.
Hi, I have a question on the 16 KB pages. So in the developer settings, I can enable this. It's going to wipe my developer device, whatever. I can test it out and see if the performance improvements there. But what does this mean for like the players? Like ultimately, they're not going to use developer options and stuff like that. So is a specific version of Android running on this by default, or what's?
Right, yeah, thank you for the question. So the question is, today we have the developer option for 16 KB mode, but that's just for developers, right? So when are users actually going to be able to use this? The reason for the developer option is because we want developers to have a platform to test their apps and make sure it's ready and debug or maybe explore some of the opportunities that 16 KB pages has to offer. But this is all in preparation for device launches. So we expect device launches in the near future, which would be in 16 KB mode by default, right? So you should be expecting that soon.
Thank you.
Hey, Mark. Freddie for the Godot Foundation. So one of the things that we observe is that Vulkan driver across the Android landscapes is all over the place in terms of reliability. So for Angle on Android 15, is there more guarantee that the Vulkan driver will be more reliable and consistent?
That's a great question. I mean, we've heard from developers around the world, especially those that are targeting Vulkan today, that driver quality is a problem and prevents them from having that reliability. We had a lot to pack into this conversation, this presentation today, so we didn't go into all the details of where we're working, but we have a huge investment in not only improving driver quality for new devices, but also understanding driver quality in a way that developers can benefit. So for example, knowing which extensions, which areas are weak on particular SoCs or GPUs, and then providing that information to the developer. We have a plugin for Unity, and it's being incorporated into Unity as well in a mainline way that already kind of provides guidance for developers to choose which devices they should be using Vulkan on, and we will continue in that vein. There are reasons why Android users don't necessarily see updated drivers today. That's also something we've been trying to fix in the ecosystem, but there's, as one can imagine, it's a complex ecosystem with different business needs, so it doesn't have maybe the same ROI or trade-offs for end users that like PC or console would have, where they update drivers very regularly. Needless to say, we are very aware of that, and we're trying to make it as easy as possible for developers to target Vulkan reliably. And we definitely see that as the future unfolds, Vulkan will be very reliable and will meet your needs for your games.
Would there be more information shared about the Unity plugin or a roadmap to make it available to other engines?
Yeah, it's so today we're making that information available. I think forget if the source is open source. It might be already, but we will be providing that information also more transparently on our developer site. But I believe if you follow the link, I had the Vulkan testing link. That's our Vulkan page on developerandroid.com, and it covers the Unity plugin as well.
All right.
Yeah.
Thanks.
All right. Well, thank you very much for coming today, and enjoy the rest of GDC. Thanks.